In this tutorial, we will look at one of the most elegant ways to run artificial intelligence locally and for free on Mac devices, iPads and iPhones. Importantly, we also cover basics like how to find the right large language model for your device, how they work, system prompts and many more concepts. So even if you're on Android, Linux or Windows devices, you can follow this tutorial and apply the insights to other tools such as Ollama and LM Studio, which I will cover in upcoming videos. By the end of the video, you will be able to run local AI models for free on your own device, tailor them to your specific use case and even learn how you can do coding with AI on your mobile device. So make sure to stick around until the end, like this video and subscribe for future videos on this. First, we have to download the app that we're using for this tutorial. You can simply go to the App Store on your device, whether it's on iOS or macOS, and search for Locally AI. You can also find the link in the video description. Importantly, according to the developer, the app does not collect any information, so it's fully running on your device with AI models you download and no conversations are uploaded to any servers. Once you have the app downloaded, you can open it. If you have Apple Intelligence installed on your device, you can already start using the chat right away. The app will auto-select the Apple Foundation model, which is good enough for most basic tasks, such as summaries and simple text. However, even if you did not download and install Apple Intelligence, you can still use the app and download a variety of open source models. It's worth noting that many of the open source models are considerably more capable than the Apple Foundation model, so it's worth taking a look at them either way. Downloading models is really easy within Locally AI. You can tap on the sidebar icon in the upper left corner and then on the settings icon. The thing we're looking for first is the Manage Models menu. This gives us a list of different models to use. Let's look at the Gamma 4 models first. It's important to note that although this model is trained by Google, it still runs completely locally on your machine and does not send any data to Google whatsoever. This also means that you can use it when you don't have internet. For example, I was on a flight without Wi-Fi the other day and used the open source models on this iPad to help me with some work, which was quite handy. After you tap on Gamma 4, you see two different models available. Let's break them down so that you understand what they are, what they can do, and which to choose. First, we have the name, which has some information embraces behind it. We have Gamma 4 E4B and Gamma 4 E2B. Gamma 4 is the name, as you already know. The E stands for effective and the 2B and 4B stand for 2 and 4 billion parameters respectively. The number of parameters is usually given in billions, with few exceptions of tiny models that use M for millions of parameters. Generally speaking, more parameters mean a smarter, more capable model, however it will run more slowly. Fewer parameters mean a less capable model that can generate answers more quickly. If we look, for example, at the official Google documentation, we can see that, for example, the E4B model has 4.5 billion effective parameters, but a total of 8 billion embeddings. The idea is that you get a model that has the capability of an 8 billion parameter model, while only having to use 4.5 billion parameters while generating an answer. This makes it comparatively fast and works particularly efficiently on mobile devices. So to summarize, we have two model options, one with 2 billion effective parameters and one with 4 billion effective parameters. Both are more efficient by having more embeddings but needing fewer parameters to run. The description also mentions reasoning. This can be quite helpful. Reasoning or thinking usually means that the model can more or less talk to itself, trying to produce better outputs. This can make quite a difference in output quality, so that's usually something you want. The info about which iPad to use this with is also helpful as a starting point. As you can see, the 4B model is recommended for M3 iPads and newer, while the 2B model is recommended for M2 models and higher. The little colorful icons at the bottom of each model summarize this again. It's new, it has thinking or reasoning capability, it can work with vision, meaning you can send images to go along with your prompts, and it's considered best and high in CPU usage, meaning it will need quite some power and probably heat up your device. Now you can download the model you want to use, which will take a moment depending on your internet speed. If you're on an earlier iPad, for example one with an M1 chip, you can also check the other model options. You may look, for example, at the second option called Bonsai. This one is even smaller in size while still having 8 billion parameters, and it's recommended for the iPad M1. In case you forget about how the whole parameter thing works, you can see a summary here in the settings too. Once the model is downloaded, you can start a new chat and select the model you want to choose at the top. It will then show a small info saying loading model, which takes a moment. Then you can go ahead and start your chat as you would do with any other AI chatbot. Let's start with a simple prompt like "Who was Aristotle?" and without much delay the AI model starts generating an answer. Especially with such common knowledge questions, the output quality is usually quite high. I didn't turn on thinking yet, which you can easily overlook since it doesn't turn on by default. So let's turn it on and ask who Plato was. Now you can see that instead of just printing an answer, it first has this internal monologue trying to figure out how to reply. For this type of question, this doesn't make much of a difference, but it takes more time. But if you want the AI to come up with plans or more complex ideas, this can be really powerful, as we will see in a moment. Next, we can check the image feature. For this first test, I upload the cover image of a study I co-authored, which you can find in the video description. With thinking mode activated, the AI model first figures out that it's a document cover and extracts the text. So this can be helpful for translation tasks, for example. In the final output, it pretty accurately summarizes the information we can get from the text on the cover. We can also use this for images that do not primarily contain text. In the second test, I attach a photo of Notre Dame, asking the AI model what it can see in the image. While it gets most of the basic features of the building, it doesn't know the specific building as it appears and can also not come up with Notre Dame when asked. So here you can see some of the more limiting factors when using a smaller model. I would probably not trust it with very precise characterizations of image content besides text, but at least it also doesn't start imagining a random name and instead clearly states that it doesn't know which building it is. This leads me to the next parameter we can customize with local AI models in general and in the Locally AI app in particular. That is the system prompt. To access the system prompt, we go back into the settings and click on Personalization. Here we get three options. For one, we can turn personalization on and off. Then we have a field for custom instructions, which is our system prompt, and the temperature below. To write a system prompt, we first have to enable the customization. Then we can access the field. Let's do something simple at the beginning and write always rhyme. Then we can also set the temperature. As you can see from the drop-down, it allows us to choose anything from precise via creative to experimental. This controls how creative or predictable the model's answers are. A lower setting like precise makes the output more focused and consistent, while a higher setting like experimental makes it more varied. Usually default or balanced is a good middle ground to ensure that the AI has enough freedom to come up with its own response, but not drift too far off from the original goal. Since we want it to rhyme, we can set it to creative for test purposes, so that it can come up with something more unique perhaps. Now we can save our personalization and go back to the chat view to start a new conversation. If we write something like our first prompt again, who was Aristotle, we can see in the thinking that the AI understands that it has to always rhyme and thinks of ways to respond in correct rhyming patterns. Of course, this is a rather silly example, but that should not make you underestimate the potential of system prompts. In its simplest form, it saves you a bunch of writing. Let's say, for example, that you use the AI primarily to reply to emails. You can write something in the system prompt like you would do whenever you would manually start a chat with the AI. For example, I will give you an email to reply to, write a kind response starting with dear name and end with all the best Martha, don't make up details, and ask me if you need more information to reply accurately. Then whenever you have an email to reply to, you can skip the prompt and simply paste the email into the chat, and it will always follow the same pattern defined in the system prompt. Something to keep in mind when critically engaging with AI is that these system prompts are presumably and practically always used. That includes all the online AI chatbots you can think of. However, with these AI services, you have no idea what the system prompt actually looks like and no way to change it. While in many ways this can improve the output quality, it can also be used to influence the user, whether that is politically, in their behavior, or in other ways. It is worth noting that changing a system prompt is basically immediate, as we've seen. So any company can change their system prompt and the AI's behavior in an instant without the need to retrain their model or inform the user. Of course, this is not the only way in which AI systems are biased, but having control over the system prompt can be valuable when critically working with AI. To get back to practical use cases, you can also use the system prompt to focus on other more specialized tasks. Let's say we want to use AI to write code. Perhaps it should follow best practices and common formatting for that particular task, ensuring we get the most usable outputs even if we don't always explicitly ask for the correct formatting and approach. The first step would be to find a model that is especially well equipped for our particular task. Gamma 4 handles coding well, but for this task I want to try Qwen 3.5, which I find more capable for coding tasks. I already have the 9B model downloaded, which should give us more promising outputs for a more specific task like this, given its larger parameter size compared to Gamma 4. Now I can also use Qwen 3.5 to help me write such a system prompt. For demonstrational purposes, I simply ask it to write a short system prompt for a coding agent. It should help the AI produce better code and keep it to 1000 characters or less. Of course, you can be more precise, but this should already help us get started. By long pressing the reply, I can copy it and insert it in the system prompt as we did earlier as well. For the next example, I take a visual reference from Pinterest for a calendar app and insert it as a visual prompt. I do this primarily as a showcase, and you should always consider at what point you're stealing other people's concepts or when they rather serve as inspiration or a starting point from which to explore your own creativity. To the image, I add the prompt, please code a front and mock-up of this calendar app UI. Make sure it includes the large day, the month, weekday, and year. It also has to include the day indicators, differentiating the past days, the current day, and future days. Then I turn on thinking mode to make sure the AI spends some time exploring how to realize this in code. Given the more complex task, this takes a while, so I speed it up for the video. Once we have the output, we can copy the message and find a way to preview it. I usually use CodePen.ai for this since it works on all devices and lets you quickly preview what the code looks like as a website. So after clicking Start Coding, we can paste the output from the AI into the HTML field. Since I copied the whole chat output, I have to get rid of everything that's outside of the HTML tag, but you could have also scrolled up and pressed the copy button only for the relevant code in the chat. And the output is not too bad. The dates overflow a bit, but it gets the general structure, and for a one-shot prompt on the tablet, this is already pretty impressive, I'd say. From here you can go back to the chat and tell the AI what to fix, or take a screenshot and explain why it doesn't fully work yet, so the AI can fix it incrementally. But for now, let's quickly summarize what we've learned in this tutorial. We've introduced the Locally AI app for Mac, iPad and iPhone. We've learned about AI model sizes, speeds and their capabilities such as reasoning and image analysis. We've explored system prompts and how they can impact and optimize our outputs. We've even started coding with AI on the iPad and previewed it with CodePen. In the next tutorials, we will look at other tools for running large language models, AI chatbots with more customization options, and AI agents. So make sure to subscribe, turn on notifications, and like this video. You can also support my work with the super thanks. I really appreciate it, and I'll see you in the next one.